Alright, we started 7.1 the other day. We're going to continue in section 7.1 today. I have some questions for you. True or false? Three times a plus b equals 3a plus 3b. True or false? True. That one's true. How come? That's distributive property. All right, that one's true. A plus b squared equals a squared plus b squared. True or false?
False.
False. Why is that one false?
Because it's false. Because you have to do like the FOIL.
You have to expand it out, and what should you get?
A squared plus 2b plus b squared.
A squared plus 2ab plus b squared. So that one's false. A plus b cubed equals a cubed plus b cubed. That's also false? Why is that one also false?
It's like triple FOIL.
It would be like triple FOIL. Do you know what you get for an answer? No, that's one people don't usually remember. That one is false. What you should get is a cubed plus 3a squared b plus 3ab squared plus b cubed. That would be a true statement. All right, how about square root of a squared plus b squared equals a plus b. True or false?
True.
That's true?
Wait. It's plus or minus.
No, it's not plus or minus, or no, it's not true?
No, it's not true.
No, it's not true? Why not? Give me a number you like for A. Any number in the whole wide world. 1. And give me a number that you like for B. 2. All right, on the right-hand side, what's 1 plus 2? That's 3. Yeah, people usually get that one right. On the left-hand side, what's 1 squared plus 2 squared? 5. And then we do square root. Is the square root of 5 equal to 3? No. So true or false?
False.
False. All right. Oh, here's a good one. ln of a plus b equals ln of a plus ln of b. True or false? True or false?
True.
True. False. How? Well, I'm going to pick my favorite number for A. My favorite number for A is 1 this time. And my favorite number for B also happens to be 1. On the right-hand side, what's the ln of 1? What's the log of 1 for any base? 0. The log of 1 is always 0. So this is log of 1, which is 0. This is log of 1, which is 0. 0 plus 0 is 0. On the left-hand side, I have ln of 2. Is ln of 2 equal to 0? No. So true or false? False. Cosine of a plus b equals cosine of a plus cosine of b. True or false? False. Why do you say false? Because it seemed like almost all the other ones were false. Which was the only true one? The only true one was the first one, which is our good old friend, the distributive property. All these other ones are false. That is false. It also does not work for sine. If I were to use sine of a plus b equals sine of a plus sine of b, that would also be false. And again, we could pick some of our favorite numbers in the whole wide world and plug them in. Give me 2 angles that you like for A and B. A is 30 degrees. And B is 60 degrees. All right, so let's try plugging those in. What's the cosine of 30 degrees? 1/2. What's the cosine of 60 degrees? Square root of 3 over 2. Is everybody really going to let her do those backward? Cosine of 30 degrees is?
Oh, I'm doing sine.
Square root of 3 over 2. Yeah, she's doing sine. Square root of 3 over 2. Cosine of 60 is 1/2. Over here, we'd have 30 plus 60. 30 plus 60 is 90, and the cosine of 90 is 0. Does 0 equal the square root of 3 over 2 plus 1/2? No, so it's certainly not true for cosine. And you could take your numbers and plug them in and try it for sine. Doesn't work. What's that?
Is it the same for tangent as well?
Same for tangent, same for cotangent. No, it doesn't work for any of them. Okay? If I were to write some of these things in function notation, this very first one, I might write f of x equals 3x. That was the first one. And then I might write f of a plus b. And this would be 3 times a plus b. You just plug in the a plus b, which happens to be 3a plus 3b, which you could say is f of a plus f of b. The important thing is, what kind of function is this right here? Give me a name for that function. If you graph that, what do you get? You get a line. So what kind of function is that? Linear. This property, where you can plug in a plus b, and it's the same as plugging in a plus plugging in b, that's called linearity. So what kind of functions have that property? What kind of functions have a property called linearity? Linear. All these other functions that I wrote, this one that has a square, this one that has a cube, square root, ln, cosine, sine, are any of those functions linear? No, so they do not have that property. You can't just, if you have an a plus b, you can't just split it into a cosine a and a cosine b and add them together. It's not going to work. All right, so what we're going to do today is we are going to derive formulas for these things. What is cosine of a plus b? What is sine of a plus b? Here's how it works. I'm going to draw a circle. And not any old circle. I'm going to draw a very special circle. I'm going to draw the unit circle. What's the unit circle again? What's that? It goes through the point 1, 0 and 0, 1. So it has a radius of 1. That's why it's called a unit circle. All right, and then I'm going to draw two angles. I'll call this angle right here, I'll call this one V. And I'll draw this angle. And I'll call this angle U. So where would the angle U minus V be? Well, angle U is bigger than 90 degrees, right? And this angle is kind of small, right? So wouldn't this distance here from here to there, wouldn't that be, take the U angle and subtract the V angle? That would end up right there. Okay. All right. Now I'm going to draw this line right here. That line right there. If this is the angle V, and this is a unit circle, then what are the x value and the y value of that point right there on the unit circle? This point right here has cosine V sine V, or not V, I'm sorry, that's U. Cosine U, sine U, that one's cosine U, sine U. Why is that point the point cosine U, sine U? On our unit circle, how did we define cosine? Cosine was the x value on the unit circle, and sine was the y value. All right. In a similar manner, what's this point right here? Cosine V, sine V. Okay. I want to find the distance from this point to that point. How do I find distance between 2 points? I use the distance formula to find the distance between 2 points. That's correct. Lindsay?
Why are you using V instead of U over there?
Because this is my angle U, so this one would be cosine U, sine U, where this point came from my angle V. So that would be cosine V, sine V on that one. All right, so once again, what I want to do now is I want to find the distance of that line segment connecting those 2 points, and we use the distance formula. Does anybody remember the distance formula? You got a square root.
Minus y squared.
Close. No, it's x minus x squared,
Okay.
Oh.
and then plus
Y minus Y.
y minus y squared. All right, so the distance formula is the square root of, you subtract the x numbers, x2 minus x1, and you square it. And then you subtract the y numbers, y2 minus y1, and you square it. And I'm not going to go through where this comes from, but this is really just a very special case of the Pythagorean theorem, where really this is a squared, this is b squared, and if you square both sides, this distance is really c squared. It's really just the Pythagorean theorem. But we're going to have, that distance is the square root of, let's see, I'm going to have cosine u minus cosine v, whole thing squared, plus sine u minus sine v, whole thing squared.
How do you know which one's X2 and which one's X1?
How do you know which one is x2 and which one's x1? Excellent question. How do you know? It doesn't matter. Just like when you're doing slope and you have y2 minus y1, which one do you call y2 and which one do you call y1? Does it matter? No, it doesn't. As long as once I pick this one to be x2, this one has to be y2. As long as I keep them the same order, I'm fine. So I did u minus v for a reason, and we'll get to that here in a few minutes. Seth?
Would cosine u be negative?
Cosine u in this case would actually be a negative number. Yes, it would be, because we do have an angle there that's in quadrant 2.
So we have to make it negative before line.
No, we don't have to worry about that. And here's why. Because we're going to go ahead and we're going to do FOIL and we're going to expand that out. And what happens when you square a negative number anyway? It becomes positive. All right, so I'm going to go ahead and FOIL some stuff out here. This is going to be square root of, I'm going to FOIL this one out. I'm going to have cosine squared u minus 2 cosine u cosine v plus cosine squared v, and I'm short of room, so I'm going to put it down here, plus sine squared u minus 2 sine u sine v plus sine squared v. Whole bunch of junk there. All right, but I think we can simplify that. Anybody see a way to simplify that a little bit? Well, what can you tell me about cosine squared u plus sine squared u? That's 1. And at the same time, I've got a cosine squared v plus a sine squared v. That's also 1, isn't it? So, simplified down, I have square root of. Those two together give me a 1. And those two together give me a 1. 1 and 1 makes 2. Minus 2 cosine u cosine v minus 2 sine u sine v.
So that was just one possible.
I used the Pythagorean identity, which says cosine squared u plus sine squared u. That's the number 1.
Yeah,
And then these two also are the number of 1, so 1 and 1 made 2. So that's where that 2 came from. All right, we're getting there. Now I'm going to draw a new circle. And this is the hard one. Once we get this one done, the others will be easy. I promise. I hope. Here's a new circle. What I want to do is I want to take this arc right here, and I just want to turn this circle a little bit so that this point ends up right there. So we're just going to do a rotation. We're going to take this circle and we're going to rotate it so that this point ends up right there. So my arc now would start here, and it would end, it looks like it ends maybe about there. Oops, you can't see what I drew. So if I take that circle and I rotate it, I'm just taking this arc, turning it so that it stops right there. So this length is exactly the same as that length. So what's this angle right here? What angle would that be? Well, on this arc, what angle was in the middle here? It would be u minus v. So what angle is this in here? This is the angle u minus v. All right. What's this point right here? 1, 0. And what's that point right there? Cosine of u minus v. It's cosine of the angle, and our angle is u minus v now. Comma, sine of u minus v. All right, and I want to do the same trick again. I want to find the length of that line segment. What can you tell me about the length of this line segment compared to the length of that line segment up there? They're exactly the same. Lindsay?
So did we connect this previous one that we were just working on down as far as we can get it, or are we still working?
We simplified this one down as far as we can get it.
Okay.
And what we're going to do is we're going to do the same thing, and we're going to simplify this one.
Okay.
And then I'm going to take this one and I'm going to make it equal to that one because they're the same length. And that's going to give us our formula. All right, so this one, the distance would be, like I said, this is the hard one. Once we get this one done, all the other formulas will be a lot easier. This distance is going to be the square root of, again, I subtract my x numbers. That's cosine of u minus v minus 1. And then I have to square that. Plus, I subtract my y numbers. Sine of u minus v minus 0. And I square that. Alright, so I'm going to do my same FOIL trick, just like I did last time. This is going to be square root of cosine squared of u minus v minus 2 cosine of u minus v plus 1. That's what I get when I square the first thing out. Now this one's easier to square out because we got a minus 0. What does minus 0 do? Nothing, right? So when I square this one, what do I get? Well, not 0, because I've got this. I get sine squared u minus v plus sine squared u minus v. But once again, look what I have. I have a cosine squared u minus v and a sine squared u minus v. What can you tell me about cosine squared u minus v plus sine squared u minus v? That's equal to 1. And then I've got this other 1 right here. So 1 and 1 makes 2. So altogether, this is square root of 2 minus 2 cosine of u minus v. Okay, we're done, practically. I promise it's going to get better. This thing has to be exactly the same as that thing up there, because those two line segments had exactly the same length. So I can set those two things equal to each other. I have square root on one side. I had square root of 2 minus 2 cosine of u minus v equals, for the other one, I had square root of 2 minus 2 cosine u cosine v minus 2 sine u sine v, I think is what I had in that other one. Kind of a big ugly mess. What I'm going to do now is I'm going to square both sides. How will squaring both sides help? Gets rid of the square roots. So I have 2 minus 2 cosine of u minus v equals 2 minus 2 cosine u cosine v minus 2 sine u sine v. Subtract 2 on both sides. How does that help? Well, those reduce right out, don't they? And then I'm going to take both sides and I'm going to divide everything by negative 2. And when I do, I get a formula for cosine of u minus v. The formula for cosine of u minus v is cosine u cosine v plus sine u sine v. Will I ever make you come up with that again on a test? I hope not to. No, the answer is no, I will not make you come up with that on a test. But I did want you to see where that formula comes from. And unfortunately, again, it's not cosine of u minus v. You can't just do cosine u minus cosine v. That doesn't work. All right, and then I'm just going to give you the other formulas. I'm not going to work them out. The formula for cosine of u plus v is very similar. Any guesses on how this formula would be different? It just switches the sign. That's correct. This is cosine u cosine v minus sine u sine v. So once you know the cosine u minus v formula, the cosine u plus v formula is the same thing, just a minus sign changes. All right, and then there are also formulas for sine of u plus v. The formula for sine of u plus v, and it's worked out in your book if you want to see where this really comes from. It's sine u cosine v plus sine v cosine u. So notice how the letters change. Sine u cosine v, and then it's the other way, sine v cosine u. In this one, when you have a plus in the middle, you get a plus on this side also. And then, in a very similar manner, we have a formula for sine of u minus v. That's going to be sine u cosine v minus sine v cosine u. Questions on those? Tangent has a formula too. Glad you asked. Tangent of u plus v. Well, what would you do? To find tangent of u plus v, you would take the sine of u plus v and you would divide it by cosine of u plus v. And then what they do in the book, they go ahead and they divide everything by cosine u, cosine v. So what you end up with, tangent of u plus v turns out to be tangent u plus tangent v divided by 1 minus tangent u times tangent v. So you end up with for a formula on that one. And then how do you think it's going to change if I put a minus in the middle? Both of the signs change. That one becomes a minus and that one becomes a plus. So we'll write that one down too. Tangent of u minus v is tangent u minus tangent v over 1 plus tangent u tangent v. Do we have to memorize these? That's a very good question. Okay, so what kind of homework problems do we expect to see in this section? Hard ones. Well, and we'll see. I'm going to jump down to number 3. We'll go back to 1 and 2 here in a few minutes. In fact, I'm going to start with number 3, part B. Tangent of 75 degrees. How could we use the sum or difference identity to evaluate the tangent of 75 degrees? Can you write 75 degrees as a sum or difference of two really nice angles that you know? Yes, you can write it as 30 and 45. All right, so tangent of 75 degrees is the same as tangent of 30 degrees plus 45 degrees. 30 plus 45 is 75, correct? All right, then I go ahead and I can use my formula. My formula, let's see, I got to look it up on my formula sheet here. It says it's going to be tangent of 30 degrees plus tangent of 45 degrees divided by 1 minus tangent of 30 degrees tangent of 45 degrees. Could I have done it as a subtraction of two angles? Can you write 75 as the subtraction of two nice angles that you know? If you could, yeah. I mean, I could write it as 90 minus 15, but 15 doesn't help. Why not? I don't know tangent of 15. I don't know tangent of cosine of 15. So we wanted to write it as 30 plus 45 because those were the two of the angles that we know and we know well. All right, so now we just go through and we fill in all the pieces. What's tangent of 30 degrees? Tangent of 30 degrees is not 1. Square root of 3 over 3? Okay. Square root of 3 over 3. Plus, what's the tangent of 45 degrees? That one's 1, yeah. Over 1 minus, what's the tangent of 30 degrees? Square root of 3 over 3, and the tangent of 45 is still 1. So there's our answer. square root of 3 over 3 plus 1, all divided by 1 minus square root of 3 over 3. Now, typically, probably what somebody would do is they would probably take this whole fraction and multiply top and bottom by 3 over 3. Why would I multiply by 3 over 3? To get rid of the double fraction sort of deal. So square root of 3 over 3 times 3 is just square root of 3 plus 3 times 1 is 3 over 3 minus square root of 3. That one would typically be written that way. All right, let's go back up to A. Pi over 12. Can you write pi over 12 as the sum or difference of two angles that you know? I'm seeing people shake their head yes. Otherwise, the teacher wouldn't have put it on the piece of paper. That's a good answer. How can you write pi over 12 in terms of two angles that you know? What's that?
Change it to degrees.
Change it to degrees. No. We love radians. We leave it in radians. Yeah, we do. Well, what are the angles that we know? 0. What are the angles in radians that we know? 0, pi over 4, pi over 2, pi over 3, and pi over 6. And 2 pi. Okay, I'm not going to use 2 pi. So I want a pi over 12. So I need a couple of fractions that when I add them or subtract them, they need a common denominator of a 12. So of all those angles that you listed a minute ago, which two might you put together when you add or subtract, you need a common denominator of 12? How about pi over 3 and pi over 4? If I'm going to add or subtract those, the common denominator would be a 12, wouldn't it? Should I go pi over 3 minus pi over 4, or should I go pi over 4 minus pi over 3? Pi over 4 minus pi over 3? I think that's the wrong way. Which one's bigger, pi over 3 or pi over 4? Pi over 3 is bigger. So I think we can check that pi over 3 minus pi over 4 happens to be pi over 12. Because this is going to be 4 pi over 12 minus 3 pi over 12. That's 1 pi over 12. So pi over 12 we can write as pi over 3 minus pi over 4. Cosine of pi over 12 is the same as cosine of pi over 3 minus pi over 4. Then we look up our formula. Our formula for cosine goes cosine, so it's cosine pi over 3, cosine pi over 4. And then the formula for cosine, when this is a minus, this one's a plus, and then it goes sine. Sine of pi over 3, sine of pi over 4. And then we plug in all the facts we know. What can you tell me about cosine of pi over 3? It's 1/2. You didn't say that with great confidence. It is correct. It is 1/2. And what can you tell me about cosine of pi over 4? Square root of 2 over 2. Very good. Also with a little more confidence. Plus, what about sine of pi over 3? Square root of 3 over 2. Yeah, that one should be easy. If you know if you knew the cosine was 1/2, you should know the sine is square root of 3 over 2. And finally, the sine of pi over 4. Same as cosine. That's 45 degrees. That's root 2 over 2. All right, so it looks like we could write our final answer as square root of 2 plus square root of 6 all over 4. Because square root of 2 times square root of 3 is square root of 6. And then both my fractions have a common denominator of 4. Questions on that one? All right, let's go down to number 4. Write cosine of 19 degrees times cosine of 5 degrees minus sine of 19 degrees sine of 5 degrees as a trigonometric function of a single angle. What do I mean by that? Yeah, we're using the formula backward. That's exactly right. So, which formula has cosine cosine minus sine sine? Well, I go back and I look at my formulas. It's the cosine u plus v. So if I have cosine cosine minus sine sine, that's the cosine of u plus v formula. So what's the answer to this problem? That's cosine of 24 degrees. Because I simply add my angles together. 19 plus 5 is 24. Questions on that?
What did you get together? 19 and 5?
Excuse me?
So you're using cosine u minus v?
Nope, I'm using cosine u plus v. Because the cosine u plus v is the one that has the minus there. So since I have a minus there, and I had a minus there, that tells me I'm using the cosine u plus v formula. So I had to add my two angles together, 19 and 5. All right, let's go back up to number 1. Problem number 1 has nothing to do with those functions we were just talking about. Problem number 1 says let x equal 3 sine theta and substitute into square root of 9 minus x squared. Also write cosine theta and tangent theta in terms of x. All right, this is going to be a very, very, very important skill when we get to something called inverse trig functions, whatever those are. It's also an extremely important skill when you get into calculus and you do something called integration by trigonometric substitution. Whatever that means. You don't have to know what that means today, but this is what we use this for. All right, so the first thing it says to do is take x equals 3 sine theta and plug it in right there. So if I do that, what am I going to have? Square root of 9 minus 9 sine squared theta. If I plug in for the x, I have to square the 3 and square the sine. And then we can simplify that. How can we simplify that? I can't take the square root. I can't do square root of 9 and square root of that one. Remember, that's not linear. Square root is not linear. Doesn't have that property. Do what? I can bring a 3 out, yes. In fact, I'm going to do that, except I'm going to write it this way. I'm going to factor a 9 out of these two things. So I'm going to write that as square root of 9 times 1 minus sine squared theta. And you're right, I can bring a 3 out. Those are now connected by multiply. Square roots do work nicely with multiply. I can do square root of 9, that's 3. But I can do even better than that. What can I do with that 1 minus sine squared theta? Isn't it equal to cosine squared theta? It is. How come? Because that's the Pythagorean theorem, the Pythagorean identity. That's correct. So, what do we end up with? 3 cosine theta. All right, so notice what the substitution did. It kind of made things better in a sense. We started with something that had a square and a square root. We made a substitution, and the whole idea is the substitution got rid of that square root that we had from the beginning. And that's why this is an important skill, and that's where it will be important for us later on. This is a technique for getting rid of square roots. It will be very, very important when you get to calculus and you're doing integrals, whatever those are again. All right, but then it also says, write cosine theta and tangent theta in terms of x. Okay, so here's what we're going to do. I'm going to come back to this here. X equals 3 sine theta. And I'm going to rewrite that as sine theta is x over 3. So how did I get sine theta equals x over 3? I just divided both sides by 3. I'm going to draw myself a little triangle here. The right triangle. This is my angle theta. If sine theta is x over 3, then what sides can I label on that triangle? Hypotenuse is 3, and the opposite is x. And then I could go ahead and I could use the Pythagorean theorem and I could find this third side. When I do that, I'm going to get square root of 9 minus x squared. And that square root of 9 minus x squared, that showed up somewhere else in this problem, didn't it? Yeah, it was this thing back from the beginning. All right, so now that I have this triangle, I can write cosine of theta. What would cosine of theta be? Square root of 9 minus x squared over 3. Adjacent over hypotenuse. And tangent of theta would be? Opposite, which is x, over adjacent 9 minus x squared. Questions on that? All right, I want you to go home tonight or tomorrow night. I want you to do number 2 and number 6. And we'll do number 5 in class on Friday. Today's Wednesday. We'll do that one on Friday. That one's a little harder. So try 2 and 6 for homework. And bring those to me on Friday.